Hi, hello, good morning, my dear students. Welcome back to my YouTube channel, KAYAKA Maths Classes. So today we are discussing some more important examples on symmetric and skew symmetric. As you have seen the last class, that is, we have started 3-mark questions on matrices. Today we'll continue the same and we'll solve some different kinds of example for 3 marks. Let us see one important example. So for the matrix A, 1, 5, 6, 7, verify that A plus A dash is symmetric matrix and A minus A dash is skew symmetric matrix. Again, it is quite similar to the previous example which you discussed in the previous class. So why it is different from the previous to this in the sense, in the previous example he hasn't mentioned the matrix and he has asked to prove A plus A dash is symmetric and A minus A dash is skew symmetric. The proving quantity same previous example and here also, but the difference is here he has mentioned the matrix. Using the matrix we need to prove here. Previously we have used some of the properties to prove. Okay, let us take. So we need to prove A plus A dash is symmetric first. Let us see. So first solution in the sense, let us take A is equals to 1, 5, 6, 7 and A dash already you know it, changing rows into column, that is 1, 5, 6, 7, isn't it? Okay, this is first part. Now let us solve the first one. So A plus A dash is symmetric in the sense, first let us find A plus A dash now. So you should remember the definitions compulsory again as of the previous classes. We have discussed the definition again. To prove it is a symmetric, you apply the transpose to the matrix and you should get it as A. That is A dash should be equals to A, and if A dash is equals to minus of A, then it is called as skew symmetric. You remember these definitions compulsory to prove them as symmetric and skew symmetric. So I'll take matrix A here plus A dash. That is A is 1, 5, 6, 7 and this is 1, 6, 5, 7. And we need to prove it as symmetric and skew symmetric. Let us see. Just add them, what you get. How to add? Already you know that. First element with first 1 plus 1 is 2. 5 plus 6 is 11, 6 plus 5 is again 11, 7 plus 7 is, so this is your A plus A dash. Now we need to prove A plus A dash is symmetric. To prove symmetric, apply transpose to the matrix. Just apply the transpose. So what it becomes? A plus A dash whole dash. Transposing to LHS as well as RHS. You can write it on both sides also. Okay. So what is the RHS becomes? It is a matrix. So if you apply transpose to the matrix, just change rows into column, simple. Just first row is first column. 2, 11, 11, 14, 11, 14. And you can see A plus A dash whole dash is equals to whether this matrix is A plus A dash or not. We'll take this as matrix A. A plus A dash, 2, 11, 11, 14. A plus A dash whole dash is also same thing, you can observe. Can I write its name here? That is A plus A dash. This implies A plus A dash is what it is? Yeah, symmetric matrix. This is the first part. What we have done, he has asked A plus A dash to symmetric. First find A plus A dash. So A plus A dash, this is a sum. Then to prove it is symmetric, just apply the transpose on both sides. Here it is transpose, and the transpose will be just changing rows into column. Again, these are true same matrices and these two will be equal. If they are equal, this is a matrix of dash, again you will get the same matrix. It is a symmetric matrix, isn't it? Just look into it. Okay. Now similarly, we'll prove for the second part also. What is the second part? Skew symmetric. For skew symmetric, what we need? A minus A dash. Let us see A minus A dash. A minus, this is A, this will be A dash. Okay. Now take what is A here? 1, 5, 6, 7. 1, 5, 6, 7. And A dash is 1, 6, 5, 7. 1, 6, 5, 7. And now subtract it. Simple subtraction. Addition, subtraction remains the same. Same element has to be subtracted and added. So 1 minus 1 is 0. 5 minus 6 is minus 1. 6 minus 5 is plus 1. 7 minus 7 is 0. And this is our a minus a dash. I'll take this as equation 2. Now to prove it is skew symmetric, what we need to do? Yes, apply transpose on both sides to this equation only. What it becomes? A minus a dash whole dash is equals to. Again, in the RHS also we need to make the same. So transpose of a matrix is nothing but just change the rows into columns from the second equation. That is 0 minus 1 becomes 0 minus 1. 1 0 becomes 1 0. You can observe these two are same. 0 minus 1 and minus 1 0 are the same. Yes, they are not same. Here it is 0 minus 1. We have 0 1 here. What you need to do take is just apply minus sign on both sides in this matrix. Let us say. So I'll take minus sign here and I'll apply one more minus because minus into minus becomes plus, or you can say it as taking minus sign is common from the matrices. You can say anything. So multiplying minus sign into the bracket, 1 is keeping outside. So 0 minus 1 minus minus plus 0. Okay. You can say this is my negative sign is common. The negative sign is common. So whenever you take minus sign as common, okay, the plus terms becomes minus, minus term becomes plus. 0, no change as it is. Plus becomes minus, minus becomes plus, and 0 as it is. Okay. So this is our a minus a dash whole dash. Isn't it the same thing? 0 minus 1, 1 0. Can I write this as a minus a dash? So therefore, a minus a dash whole dash is equals to this minus sign as it is a minus a dash because of equation number 2. This matrix is as same as equation 2. I can write. So this is proven already. The matrix dash is equals to negative of the matrix. Matrix dash is equals to negative of the matrix. Instead of a, you have a minus a dash. Here instead of a minus a dash. Isn't it? Therefore, a minus a dash is skew symmetric. Isn't it so simple, my dear students? Yes. Using the matrix, we are proving it as symmetric and skew symmetric. Just adding the two matrices and applying the transpose. Just subtracting the two matrices and apply the transpose. And here what you need to take? You need to take minus sign as common to get your a minus a dash equation to add. Just look into it. Welcome back, my dear students. We'll see one more example on symmetric matrices. Little bit of different things. Again, let us see. If A and B are symmetric matrices, again he is giving A and B are symmetric matrices, then show that AB minus BA is a skew symmetric matrix. So as I said you in the previous examples and the previous videos also, if anything asked on symmetric and skew symmetric, please remember in your mind and fix it that you should remember the definition and the conditions for symmetric and skew symmetric compulsorily. So here it is written, you should have fixed in your mind what is the condition for symmetric, what is the condition for skew symmetric. Then you can easily prove these problems without any doubts, without any hesitations. Okay, let us see, let us simplify this and find the solution in the easiest way. Let us see. What he has given, A and B are symmetric matrices. Let us write the given thing. A and B are symmetric matrices. Symmetric matrices in the sense, condition is what? A dash is equals to A. And he has given A and B both. So this implies A dash will be A and B dash will be B. Isn't it? According to the definition, symmetric in the sense A dash is equals to A. A is symmetric, A dash is equals to A. B is symmetric, B dash is equals to. These two conditions should be used to prove it is skew symmetric. Okay, what he is proving? AB minus BA. Let us say. Let us take C is equals to AB minus BA. Okay. Now applying transpose on both sides. Applying transpose on both sides. To prove it is symmetric or skew symmetric, what he has asked, you just consider that and apply the transpose. That is one thing you should remember. So what it becomes, C dash is equals to AB minus BA whole dash. C becomes C dash. The whole term dash has to be taken. So what this becomes, now you apply the transpose to the first term as well as second term separately. How it will be? AB dash minus BA dash. Isn't it? Isn't it? Right. Now you need to expand the dash of AB and expand the dash of BA. Dash and says transpose. So you should remember few things here. AB whole dash can be written as B dash A dash. So whenever we are distributing the transpose property to the multiple of two matrices, it can be expressed as AB whole dash can be written as B dash into A dash, because in matrix multiplication is not equal, that is AB is not equals to BA. So compulsory you should write B dash into A dash only. Let us see. So AB whole dash can be written as B dash into A dash minus BA whole dash. BA can be written as again the reverse of this, that is A dash into B dash by the same property. Second vector, second matrix minus first matrix. Whenever you are applying the transpose to the multiple of two different matrices. Okay. So what it becomes? Now let us replace A dash value as A and B dash value as B from equation number 1. So B dash as B, A dash as A. Again A dash as A, B dash as B. This is because of equation number 1. Are you following this? Yes. Now C dash is equals to BA minus AB. Can I write what it is? So this is our equation 2. Let us take. Okay. Now you take minus sign as common. Whenever we are solving for skew symmetric, you need to take minus sign as common compulsory to prove that it is a skew symmetric, because C dash should be written as only C. Then only it is a skew symmetric. If I take minus sign as common here, what it becomes? My negative becomes positive, that is AB plus BA becomes minus BA. So this minus as it is, AB minus BA is vector C. So C dash is equals to minus C. That is, what is C here? What is C? AB minus BA whole dash is equals to minus of AB minus BA. If a matrix is there, if you applied the transpose and you obtain negative of the same matrix, what we call it is? If a matrix is there, we have applied the transpose. If I obtain minus of the matrix itself, then we call it as a skew symmetric. So we obtain C dash is equals to minus C. Then it is a skew symmetric matrix. It is as simple as that. Therefore, AB minus BA is skew symmetric matrix. Isn't it so simple? Isn't it easy, my dear students? Yes? Are you following this? I hope. So please go through with all the 4 or 5 examples which you have solved. So only there may be change in the matrix elements, a little bit of change. The conditions remain same. This definition plays very important role whenever we are solving the problems on symmetric and skew symmetric. So please, if you are following this, watch all the previous videos for your exam preparation. So I hope everybody has understood this concept. So we'll continue the next class with another important topic for 3 marks. Okay. So please like, share and subscribe. See you. Thank you.